What's up, AP Chemistry people? So today we get to balance redox reactions. So we recognize that it's redox because we've got electrons trading places. Since electrons are trading places, however many electrons our thing getting oxidized loses, our thing getting reduced has to gain. So when we first started doing balancing reactions, we said, hey, you can't change mass. So whatever chemicals you start with, you have to end with the same amount of different chemicals, but total atoms have to be the same. Well, not only do total atoms need to be the same, electrons need to be the same. So when we have redox equations, we really ought to redox balance them. It also allows us to balance some things we couldn't otherwise balance without this. So if you haven't already, grab your book or pause me and look at the things here, the steps to balance, because it's a little different than just say, hey, balance your nitrogen, balance your oxygens, and you're good to go, right? So you've got to do it. It's a little more step-by-step process, but it works well, right? So, but your basic steps are divided into half reactions, balance everybody other than hydrogen and oxygen, balance your oxygens with water, balance your hydrogens with H+, balance your electrons, and then multiply your half reactions together to basically get least common multiples of electrons, and then you add stuff together and cancel them out. So we're going to go ahead and bounce to the board and work a couple problems. So this will be the first problem that we'll do. I know it can be kind of hard to see the board, so you might go ahead and write it down there, and then we'll jump to the board. So first thing we need to do is break this guy in half. You don't actually have to identify what's your oxidizing agent, what's your reducing agent, which one's getting oxidized, but that's what you're doing, is you're separating it into a redox half, or a reduction half and an oxidation half. So I'm going to grab this first one, CR, this marker is trash. CR2O7 minus 2 goes to CR plus 3. So that is one of my half reactions. My other half reaction is Cl minus goes to Cl2. So the first thing I need to do is break it into halves. That is done. I broke it into halves. Second thing I need to do is balance everybody who is not hydrogen and oxygen. I see two chromiums here, so I better put a 2 here. Now my chromiums are balanced. That's not very hard. I check my second half reaction, and I say, well, I've got that balanced now. All right, so I balance everybody who is not hydrogen and oxygen. Now I come through and I balance my oxygens with water. So I find my oxygens and I say, well, I've got 7 oxygens here. So how can I balance that out? Where do I need to put what? I need to put water right here, and I need to put 7 of them there. That's a bunch, right? Well, there's 7 oxygens. I got to balance those 7 oxygens out. They went somewhere, right? So they're going to go into water. And then I need to balance out my hydrogens. So I tend to do these in a pair on each half. So I'll take care of my waters or my oxygens, and then right away with my hydrogens. So plus 14 H pluses. A lot of these things happen in acidic environments, right? So then I do the same thing down here. Well, there's no oxygen, there's no hydrogen, so done, right? So now I need to come through and do my electrons. I am on to step 5. So electrons, maybe take a second and figure out the charge on chromium. Oxygen is -2. There are 7 of those, so that's -14. Something minus 14 equals a -2. Well, this must be 12, so my charge on chromium is +6, and there's 2 of those +6s, right? So that is a +6 chromium, but there are 2 of them. So total, I've got a +12 right here. Here they are +3 and +3, so that's +6. So all total, I have gained 6 electrons, right? So to balance these 2 charges out, I need to balance out this total +6 and this total +12. So that means I need 6 electrons over here. That's kind of smushed there on the edge, right? But I've got 6 electrons right here because my 6 negatives and my 12 positives balance out to 6 pluses, right? So we see how that electrons works. Try that on the chlorines without me first. Pause me if you need to. So I've got a -1 here, and there are 2 of those -1s, so that's a -2. There are a couple of zeros here, so that means I have 2 electrons I need to deal with. Well, this side has too many electrons, so that means I need those 2 electrons over here. All right, so that is my electrons getting balanced on each half reaction. I'm going to go ahead and erase the extra stuff around here. So right now, in case you can't read my awful handwriting, it's 6 electrons and 14 hydrogens, and then a Cr2O7 minus 2, a dichromate, makes a chromium plus 2 chromium plus 3s and 7 waters. I have 2 chlorides reacting to make 1 chlorine molecule and 2 electrons there. So my next thing is to cancel out my electrons. So I need there to be the same number of electrons in each half reaction, because if this side needs 6 electrons on this side, I need 6 electrons on this side to balance out with that, right? So this side's absorbing 6 electrons, so this side needs to be donating 6 electrons, right? As we think about that, my chromium here is gaining electrons, right? There's some electrons to gain in this chromium. So if it's gaining electrons, that's reduction. This guy is losing electrons, so that's oxidation. So this is my oxidation half, this is my reduction half. I need to take my oxidation half, my losing electrons half, because I'm producing those, and multiply it by 3. If I multiply that by 3, that's going to give me 6 electrons on both sides. So my 6 electrons there. So if I multiply both sides by 3, that's going to give me a 6 here, a 3 here, and a 6 here. So now I cancel out those electrons, and anything else they can cancel out as I add them back together. So as I add them back together, I'm going to go ahead and use red. So I'm going to say 14 H pluses plus Cr2O7 minus 2 plus 6 Cl minuses is going to make Cr2 Cr plus 3s plus 7 waters plus 3 chlorines, plus 3 chlorines. Right? I don't know if it's easier to see that with the lights on or off. It feels like it's easier to see stuff with the lights off when I look at the videos. So but that red's kind of hard to see, but I want it to be in a different color. Right? So hopefully that helps. I'm going to make each one of these a different video because YouTube is cutting off my videos if they're longer than like 14 minutes. So I'm going to make each redox problem a different problem, and I'm going to put just several up here because you've got to do a bunch of these to get good at them. But it's the same process every time unless we go to basic ones, which we'll get to here in a few days.